Hi everyone, and welcome to this video channel Science Class I. Mutung Gopal Singh, welcome to this learning of Science Class I. In the previous video class, we studied chapter number 2, Microorganisms, Friend and Foe. And in today's video class, let's study chapter number 4, Materials, Metals and Non-Metals. And it is in textbook page number 44. Let's see it. Here let's see, you are familiar with a number of materials like iron, aluminum, copper, etc. Some materials have been given in table 4.1. Table 4.1, appearance and hardness of materials. Here iron, coal, sulfur, aluminum, copper are given. Iron, it is shiny, and hardness, it is very hard. Coal, it is dull, and hardness is not very hard. Sulfur, it is dull and hardness is not very hard. Aluminum, it is shiny and hardness is very hard. Copper, appearance is shiny and hardness is very hard. Can you name the materials which are metals? The rest of the materials in table 4.1 are non-metals. Metals can be distinguished from non-metals on the basis of their physical and chemical properties. Recall that luster and hardness are physical properties. So, out of these materials, iron, aluminum, copper, they are all metals. Let's see. Physical properties of metals and non-metals. Have you ever seen a blacksmith beating an iron piece or an article made up of iron like a spade, a shovel, an axe? Do you find a change in the shape of these articles on beating? And would you expect a similar change if we try to beat a piece of coal? Let's see. Let us find out. Activity 4.1. Your activity is there. Take a small iron nail, a coal piece, a piece of thick aluminum wire and a pencil lead. Beat the iron nail with a hammer, figure 4.1. It is shown here. But take care that you don't hurt yourself in the process. Try to hit hard. Hit hard. So here in figure 4.1, beating an iron nail with hammer is shown here. So the aluminum wire also. Then repeat the same kind of treatment on the coal piece and the pencil lead. Record your observations in table 4.2. So when we beat iron nails with a hammer, then the iron nail will become broke. And when we beat in the pencil lead, then it will broken down. Let's see. In table 4.2, malleability of materials, object materials. Say iron nail. Iron nail, it can change its shape. Iron nail can become flattened. And coal piece, it breaks into pieces when we hit it by using a hammer. Aluminum wire. Aluminum wire, when we hit it by using a hammer, then it becomes change in shape. That means it becomes flattened. Pencil lead, then it breaks into pieces because it is fragile material. Next, let's see textbook page number 45. You saw that the shape of the iron nail and the aluminum wire changed on beating. If they were beaten harder, these could be changed into sheets. You might be familiar with silver foil used for decorating sheets, and you must also be familiar with the aluminum foil used for wrapping fruit. The property of metals by which they can be beaten into thin sheets is called malleability. So malleability is one of the property of metals that in which they can be beaten into thin sheets. That property is called malleability. This is a characteristic property of metals. As you must have noticed, materials like coal and pencil lead do not show this property. Can we call these metals? No, they are not metals. Can you hold a hot metallic pen, which is without a plastic or a wooden handle, and not get hurt? Perhaps not. Why? Try to list some other experiences in which a wooden or plastic handle protects you from being hurt while handling hot things. On the basis of these experiences, what can you say about the conduction of heat by wood and plastics? So, heat can be transferred from one region to another, and that transfer of heat from one region to another takes place by a method that is called conduction. You must have seen an electrician using his screwdriver. What kind of handle does it have? Why? So electrician use a screwdriver and its handle is made of plastic because plastic is non-conductor. So let us find out activity. Activity 4.2. Recall how to make an electric circuit to test whether electricity can pass through an object or not. Figure 4.2, let's see, you might have performed. Here, electric tester is here. Electric tester. This is the bulb, and this is the drive shell, and this is the connecting wire. So, this wire is connected through this iron nail. This shows iron nail can pass through electric current. That means it is conductor. Next, the activity with various objects in class 6. Now repeat the activity with materials mentioned in table 4.3. Say observe and group these materials into good conductors and poor conductors. Table 4.3, electrical conductivity of materials. Let's see. Serial number 1, 2, 3, 4 are given. Materials: iron rod or nail, sulfur, coal piece, copper wire. Good conductor or poor conductor. Iron rod or nail, they are good conductor. Sulfur, they are poor conductor. Even they are non-conductor. They are. Number 3, coal piece, copper wire. Let's see. You observe that iron rod, nail and copper wire are good conductors, while rolled sulfur piece and coal piece are poor conductors. Then here, the meaning of recalling our experience and then of this activity was to show that metals are good conductors of heat and electricity. We learned this in class 6. In class 6, we learned metals are good conductor of electricity. Where do you find the use of aluminum and copper wires? Let's see. Aluminum and copper wires are used in the as electrical wires. So let's see, have you seen wires of coal? We even don't see wires made of coal. Definitely not. The property of metal by which it can be drawn into wires is called ductility. So ductility is one property of metal by which it can be drawn into wires. That is called ductility. Have you ever noticed the difference in sound on dropping an iron sheet or plate, a metal coin, and a piece of coal on the floor? If not, you can try it now. Do you note any difference in the sound produced? Okay, next page number 46, let's see. In textbook page number 46, have you seen wooden bells in temples? Can you give a reason? The things made of metals produce a ringing sound when struck hard. Suppose you have two boxes similar in appearance, one made of wood and the other of metal. Can you tell which box is made of metal by striking both the boxes? So we cannot see bells, wooden bells used in temples. So bells are made from the metals. So bells used from metals are used in most of the temples because they produce sound. Since metals produce ringing sounds, they are said to be sonorous. The materials other than metals are not sonorous. So non-metals are not sonorous. After performing the above activities, we can say that some materials are hard, lustrous, malleable, ductile, sonorous, and good conductors of heat and electricity. So these are the properties of metals. Properties of metals. The materials which generally possess these properties are called metals. So metals can be hard, lustrous, malleable, ductile, sonorous, and good conductors of heat and electricity. These are the properties of metals. The examples of metals are iron, copper, aluminum, calcium, magnesium, etc. In contrast, materials like coal and sulfur are soft and dull in appearance. They break down into a powdery mass on tapping with a hammer. They are not sonorous and are poor conductors of heat and electricity. These materials are called nonmetals. The examples of nonmetals are sulfur, carbon, oxygen, phosphorus, etc. Metals like sodium and potassium are soft and can be cut with a knife. Mercury is the only metal which is found in liquid state at room temperature. These are exceptions. Chemical properties of metals and nonmetals. Let's see. Reaction with oxygen. You are familiar with the phenomenon of rusting of iron. Recall the reaction by which rust is formed. You had also performed in class 7 an activity of burning a magnesium ribbon in air. You had learned that in both the processes, oxide formation takes place. Complete the following reactions of iron and magnesium with oxygen. Okay, magnesium with oxygen. So here, let's see reaction iron with oxygen and water. It gives magnesium plus oxygen. Then what? Here, activity 4.3, let's see. Let us check the nature of rust formed as a result of the reaction between iron, oxygen, and water. Collect a spoonful of rust and dissolve it in a very little amount of water. You will find that the rust remains suspended in water. Check the suspension well and test the solution with red and blue litmus paper. In figure number 4.3. What do you observe? Is the solution acidic or basic? Testing the nature of rust. This is activity. Rust is here. Red litmus paper. Rust suspension is here. It is inside test tube. Next. Does copper also get rusted? I have seen a greenish deposit on the surface of copper vessels. When a copper vessel is exposed to moist air for long, it acquires a dull green coating. The green material is a mixture of copper hydroxide and copper carbonate. The following is the reaction. This is the reaction. That is moist air. Now recall the activity of burning magnesium ribbon. The ash obtained on burning magnesium ribbon is dissolved in water and tested for its acidic or basic nature. Is the solution acidic or basic? How do you ascertain this? You must have observed that the red litmus turns blue. So, oxides of magnesium is also basic in nature. In general, metallic oxides are basic in nature. Let us now observe the reaction of nonmetals with oxygen. Activity 4.4, let's see. To be demonstrated by the teacher in the class. This is just an activity. So we have to take a small amount of powdered sulfur in a deflagrating spoon and heat it. If deflagrating spoon is not available, you may take a metallic cap of any bottle and wrap a metallic wire around it and give it the shape shown in figure 4.4a. Figure number 4.4, let's see. As soon as sulfur starts burning, introduce the spoon into a glass jar or glass tumbler. In figure 4.4a, cover the tumbler with a lid to ensure that the gas produced does not escape. Remove the spoon. After some time, add a small quantity of water into the tumbler and quickly replace the lid. Shake the tumbler well. Check the solution with red and blue litmus paper. Figure number 4.4b. Here, burning of sulfur powder. Activity is shown. Improvise deflagrating spoon. And in figure number 4.4b, testing of solution with litmus paper. Here. Okay, now let's see in textbook page number 48. Table 4.4, metals and nonmetals in acids and bases. Share number 1, 2, 3, 4, 5 are given. Name of base, calcium hydroxide, metal, calcium. Name of the acid, sulfuric acid are given. It is nonmetal. Nonmetal means sulfur. So, the name of the product formed in the reaction of sulfur and oxygen is sulfur dioxide gas. When sulfur dioxide is dissolved in water, sulfurous acid is formed. The reaction can be given as follows. Sulfur dioxide reacts with water, then sulfurous acid is formed. The sulfurous acid turns blue litmus paper red. Generally, oxides of nonmetals are acidic in nature. Recall the name of some of the laboratory acids and bases you have read in class 7 and note down their names in table 4.4. Identify the metal or non-metal present in them which forms oxides with oxygen. Reaction with water. Let us see how metals and non-metals react with water. Sodium metal is very reactive and it reacts vigorously with oxygen and water. A lot of heat is generated in the reaction. It is therefore stored in kerosene. Sodium metal is generally stored in kerosene because it is very reactive. It vigorously reacts with oxygen and water because of that. Activity 4.5. This also to be demonstrated by the teacher. During demonstration, special care should be taken that the size of the sodium metal piece is roughly the size of a wheat grain. It should be held with a pair of tongs. Let's see. Take a 250 ml beaker or glass tumbler and fill half of it with water. Now carefully cut a small piece of sodium metal. Dry it using filter paper and wrap it in a small piece of cotton. Put the sodium piece wrapped in cotton into the beaker. Observe carefully. During observation, keep away from the beaker. When a reaction stops, touch the beaker. What do you feel? Has the beaker become hot? Test the solution with red and blue litmus papers. Is the solution acidic or basic? So, reaction of sodium with water is shown here. In the next point, you observe that sodium reacts vigorously with water. Some other metals do not do so. For example, iron reacts with water slowly. Generally, non-metals do not react with water, though they may be very reactive in air. Such non-metals are stored in water. Say, for example, phosphorus. Phosphorus is a very reactive non-metal, and it catches fire if exposed to air. To prevent the contact of phosphorus with atmospheric oxygen, it is stored in water. And next, reaction with acids. Let us see how metals and non-metals behave with acids. Here, activity 4.6. Warning. Let's see. Keep the mouth of the test tube away from your face. Use test tube holder to hold the test tube. So we have to do this activity very carefully. To the mouth of the test tube, keep away from our mouth. Take samples of metals and non-metals listed in table 4.5 in separate test tubes and label them as A, B, C, D, E, and F. With the help of a dropper, add 5 ml of dilute hydrochloric acid to each test tube, one by one. Observe the reactions carefully. If no reaction occurs in the cold solution, warm the test tube gently. Bring a burning matchstick near the mouth of each test tube. Repeat the same activity using dilute sulfuric acid instead of the dilute hydrochloric acid. Record your observations in table 4.5. Here in table 4.5, reaction of metals and non-metals with acids. Test tube label as A, B, C, D, E, F. Metals or non-metals. Say magnesium ribbon. Reaction with dilute hydrochloric acid at room temperature and at warm. Reaction with dilute sulfuric acid at room temperature or warm. So from this activity, say we will learn from the next page is there a difference in the way Metals and nonmetals react with acids. What could the pop sound in some cases be due to when a burning matchstick is brought near the mouth of the test tube? You must have found that nonmetals generally do not react with acids, but metals react with acids and produce hydrogen gas that burns with a pop sound. So you must have noticed that copper does not react with dilute hydrochloric acid, even on heating, but it reacts with sulfuric acid. Reactions with base. Let's see. Activity 4.7. To be demonstrated by the teacher. During the preparation of sodium hydroxide solution, care should be taken that pellets of sodium hydroxide are handled with a plastic spatula. Prepare a fresh solution of sodium hydroxide in a test tube by dissolving 3 to 4 pellets of it in 5 ml of water. Drop a piece of aluminum foil into it. Bring a burning matchstick near the mouth of the test tube. Observe carefully. Here, what does the pop sound indicate? As before, the pop sound indicates the presence of hydrogen gas. It shows the presence of hydrogen gas. Metals react with sodium hydroxide to produce hydrogen gas. Reactions of nonmetals with bases are complex. Displacement reaction. Let's see. Recall the activity of the reaction between copper sulfate and iron that you performed in class 8. Let us observe some more reactions of that kind. Activity 4.8. Take 500 ml beakers and label them A, B, C, D, and E. Take about 50 ml of water in each beaker. Dissolve in each beaker a teaspoonful of each substance as indicated in figure 4.6a. Keep the beakers undisturbed for some time. Record your observations in your notebook. Here, beakers are labeled as A, B, C, D, E. And here, copper sulfate solution, iron sulfate solution are here. Beaker A, copper sulfate solution with zinc granule. Beaker B, copper sulfate solution with iron nail. Beaker C, zinc sulfate with copper turnings. And beaker D, iron sulfate solution with copper turning. Beaker E, zinc sulfate with iron nail. Figure 4.6, A and B, displacement reaction. A and B, these are displacement reaction. So here you see, what changes do you observe in the various beakers? You have read that one metal displaces another metal from its compound in aqueous solution. In beaker A, zinc replaces copper from copper sulfate. That is why the blue color of copper sulfate disappears and a powdery red mass of copper is deposited at the bottom of the beaker. The reaction can be represented as follows. Copper sulfate with zinc, it gives zinc sulfate with copper. So zinc sulfate is colorless, copper sulfate is blue color. You can write down the reaction taking place in beaker B in a similar manner. Here, I have understood the reactions taking place in beakers A and B, but I am still confused why there is no change in beaker C, D, and E. There could have been displacement of zinc by copper in beaker C and by iron in beaker E. Similarly, iron could be displaced by copper in beaker D. Since we do not see any change in beaker C, we can infer that copper is not able to replace zinc from zinc sulfate. But why? When zinc can replace copper in beaker A, why cannot copper replace zinc in beaker C? Remember that science is not arbitrary. It follows definite rules based on facts. And the rule here is that zinc is more reactive than copper and iron. So zinc is more reactive than copper and iron. A more reactive metal can replace a less reactive metal, but a less reactive one can replace a more reactive metal. Now you can understand why there are no displacement reactions in beakers D and E also. Can you guess the sequence of metals from more reactive to less reactive among zinc, iron and copper? Uses of metals and nonmetals. Let's see. You should be able to guess why metals are used in making machinery, automobiles, aeroplanes, trains, satellites, industrial gadgets, cooking utensils, water bodies, etc. You are also familiar with the uses of some nonmetals. Here are some interesting ones. We are sure that you will guess them right. Nonmetal is essential for our life, which all living beings inhale during breathing. Point number 2, nonmetals used in fertilizers to enhance the growth of plants. Point number 3, nonmetals used in water purification process. Point number 4, nonmetal used in the purple color solution which is applied on wounds as an antiseptic. Nonmetals used in crackers. You may add some more uses of metals and nonmetals from your experience. Here, I heard that magnesium is found in plants. In what form is it found in them? This girl said, I heard that magnesium is found in plants. In what form is it found in them? Next, the doctor reported iron deficiency in my body. Where is iron in my body? Okay. In class 7, you have learned that in a chemical reaction, new substances are formed. These substances are different from those which underwent the reaction. Now, if a substance cannot be broken down further by chemical reactions, by cooling, heating, or by electrolysis, it is called element. Sulfur is an element. So is iron. Carbon 2. So iron, carbon 2 is an element. The smallest unit of an element is atom. Don't forget, the smallest unit of an element is the atom. A sample of an element contains only one kind of atom. In a sample of an element, it contains only one kind of atom. The atom of an element remains unaffected by physical changes in the element. So, for example, say an atom of liquid sulfur would be exactly the same as the atom of solid or vapor sulfur. So, the element may be in different state, but their atom will be same. This is the point. Although we have an infinite variety of substances in the universe, the number of elements forming these substances is limited. and there are no more than 94 naturally occurring elements. So far, there are no more than 95 naturally occurring elements. An important classification of element is in terms of metals and non-metals. So, most of the elements are metals and the remaining are either non-metals or metalloids. So, metalloids possess character of both metals and non-metals. So, materials around us can be differentiated into metals, non-metals, and metalloids. So metals, some properties of the metals are good conductor of electricity. They are sonorous, ductility and malleability are there. Whereas in non-metals, these properties are not there. And metalloids are also elements. They possess character of both metals and non-metals. So in this chapter we learn materials. They are say metals, non-metals and metalloids. Okay, for today it comes to the end of this class. In the next video class I will bring you another new topic. For today let's stop here. Bye.